Thank you everyone for coming tonight. Tonight I have the great pleasure of introducing Professor Virginia Trimble. Professor Trimble has had an extensive career in astronomy and astrophysics and has recently been awarded this incredible prize, the 2024 Abraham Pace Prize for the History of Physics. She's dialing in all the way from California, where she has just told us she's just recently given her morning seminar before coming along to deliver this talk. And it's an absolute pleasure to introduce her today. She's going to be talking about, does it count as history if I can still remember? So I'm going to hand you over to Virginia. Thank you very much.
Good morning, afternoon, or evening, depending on which time zone you happen to be in. We're going to have slight logistic problems with the images are not coming out quite right. So you're missing some of my hieroglyphs in the lower right-hand corner. I'm going to tell stories. Most of them, I hope, are true. Most of them are actually more or less firsthand. And some of the subjects are in blue here. I'm not going to tell Dirac stories. On the other hand, that quote, fiat lux compusque magneticus, that came from Fritz Zwicky in connection with his ideas of the early universe, that it was not enough for the good Lord to have said fiat lux, he also had to make magnetic fields. GRB could be either gamma ray burst or Jeffrey R. Burbage. They'll be both. Comments on astrophysics, weak gravitational lensing, and so forth. Dyson type 1 and type 2 errors. I'm going to start by looking back in the 1920s. The long 1920s included general relativity, Einstein in Berlin, as Holton said, only Einstein, only there, only then. And Einstein was going hungry. And I swear that had something to do with his later career, although nobody else has ever said it. But the Schwarzschild solution, Schwarzschild, this is Carl, was in the trenches on the Eastern Front and wrote to Einstein, got back a letter dealing with gravitational radiation, which I may get back to later or not. Anyway, Schwarzschild was dying of pemphigus as he communicated with Einstein about GR. We have the fact that K5 stars were made of hydrogen and helium, Cecilia Payne-Gaposchkin, 1925, the Friedmann solution to the Einstein equations. And over here, amongst the observations, the Kapteyn universe, Shapley on globular clusters, the Curtis-Shapley debate, galaxies exist. My thesis advisor always said the most important thing about galaxies is they exist. He wasn't interested in very much else. They also have large radial velocities. That was Slipher. You'll see a picture of him in a minute. And there's a velocity distance relation due to Edwin P. Hubble, who himself was never entirely persuaded that the universe was expanding, although most of us now think it is. Okay, there are the Shapleys and his both Vesto Melvin and Earl Clarence. What was their mother thinking of? And there is a spectrum as it appeared in 1912. That's M31. And the bits you can see are, of course, the comparison spectrum, the galaxies down the middle. There's Slipher again. And there is a variable star in the outskirts of the Andromeda Nebula. This is Cecilia Payne. That's my favorite picture of her. There are whole books about her now. This is when she got her honorary degree from Smith College, and she was clearly pleased by it. And she's wearing an academic gown. And she was the one who showed that stars are made of hydrogen and helium. This is a picture taken at the 100-inch telescope. In other words, I just barely make contact with the facilities of the 1920s. There I am looking into the mirror, and the face on the side is my thesis advisor, Guido Munch, whom you'll meet again in a moment or two or three. And it's hard to make sense of what's going on in this picture somehow. It looks like, the Earth is shining up, or what is it? Ah, of course, it's a mirror telescope. Concave mirror. Concave mirrors invert images. So there we are with our faces upside down, but the telescope right side up, and sunlight shining into the dome of the 100-inch. And I don't remember now why that was permitted, but I was being followed by a reporter that day and it was permitted. Timelines. The universe and me. I was born very early in Hollywood, California. UCLA, Caltech, the Institute of Theoretical Astronomy, as it then was, Smith College, teaching for a year, back the Institute of Theoretical Astronomy, UC Irvine, University of Maryland for 28 years, half and half, shared with my late husband, Joseph Weber. I edited Comments on Astrophysics. I was the second named editor of the Astrophysical Journal for about a decade. Meanwhile, the universe was having steady state cosmology, the discovery of radio sources, source counts. I'm trying to, no, I know what, that's the wrong thing to do. I was wondering if I could move source counts out from under the sidebar with the faces on it, but I don't think I can. Discovery of X-ray sources. There's a funny story that goes with that I won't get to otherwise unless I do it here. The first X-ray mission was a rocket set up by AS&E, and they saw the background and they saw one source, and they wanted to know what star was that source. So according to Herb Gursky, they bought a star atlas and they opened it. They discovered there are a lot of stars out there. It took much better angular resolution to identify the early X-ray sources and also the early radio sources. If you think about the fact that theta is lambda over D, quasars, point sources very nearly, and to locate the first one, 3C273, required special arrangements with a lunar occultation to get a good position of it. And we then get the cosmic microwave background. I have some stories that go with that. Things about the Crab Nebula. The year that goes with Crab Nebula, of course, is 1054, when the light first reached Earth, not when the event went off, which was a few thousand years before that. We had some theses on the subject, the first one by Lodewijk Volcher, the second one by Bob Williams, who later became director of the Space Telescope Science Institute and used all his director's discretionary time to do the Hubble Deep Field. They aimed for hours at utterly empty skies. People thought he was nuts, but what they discovered is galaxies were different in the past. Theses by Trimble and Scargill and Sam Okoye, who we'll meet. You get a nice picture of Sam Okoye in a minute. Pulsars from 1967 on, one in the Crab, Cygnus X1 as a black hole, and gamma ray bursts. And there's a list of the editors of Astrophysical Journal, headed by Helmut Abt, who ran it. He ran it by himself for about a decade and then took on associates of various sorts. Chandrasekhar, of course, had run it on his own for almost 25 years. And there's the masthead of Comments, of which I was the senior whatever it was for about the same decade. That was actually useful. Occasionally, one had to reject a paper from AppJ because it was a little too unconventional. I could always say, well, we'll give it a home in Comments. And this happened. Solar neutrinos. Once upon a time, this story is secondhand from Maurice Goldhaber, but once upon a time, in the mid-1960s, Ray Davis and John Bacall came to Maurice, who was then head of research at Brookhaven National Lab. And Ray Davis said he could detect that many neutrinos, and John Bacall said the sun would make that many neutrinos. Could they have some money? And Maurice said no. But they came back a little later. And John said, well, I can make that many neutrinos. And Ray said, well, I can detect that many neutrinos. So indeed, it was funded. And in due course, this led to first the solar neutrino problem, that when they were detected, there were fewer than was expected by a factor of 3. And there was a conference on that in 1971. You'll see pictures of it in a minute. The right idea was already there. It came from Bruno Pontecorvo, who was then in the Soviet Union. He returned to the West, at least to Italy, where he was born, of course. A few years afterwards, I just barely met him. But John Bacall appears in other stories. Statistics of quasar absorption features. He was quite right. Although the funny remark about this was that he said, these results came from a computer, so they must be right. And then he headed up the 1990 American Decadal Survey. And I'd volunteered for a bunch of things. I volunteered again this past decadal for a lot of things. They didn't want me for anything. But 1990, I thought I'd been left out because almost all the committees had been settled. And then John Bacall phoned and said, would I head up a particular one of the committees for the 1990? So this was Cinderella gets to go to the ball. And out of the Solar Neutrino Conference came a paper that really is Trimble and Reines, but of course everybody cites it as Reines and Trimble. We're going to hit some sociology things, productivity and impact. The most important thing is the right size community and the right people in the community. They have to want the data very badly. That's why remote observing has never worked quite as well as the guy having to be there, or the gal having to be there. Genders of authors and their papers. Papers with female first authors are accepted a little more slowly than papers with guys as first authors. Long Range Fate of the Decadals. Michelle Pan and I have been working on this. We're going to set a funny record. She's starting as an undergraduate at Stanford in the fall at age 17. I started at UCLA as an undergraduate at age 17 in 1961. I think we're going to set a record for difference in ages between co-authors. Of course, the solar neutrino problem, everybody blamed everybody else. The astronomers blamed the physicists blamed the chemists blamed the astronomers. But it turned out that the real problem was in the basic physics, the oscillation. Oh dear, this is not the vision I had. That's supposed to be a full screen of the Solar Neutrino Conference, 1971, at the Western White House. Came out right on mine.
We're getting a very small picture there of
yes,
the
I know
top.
that's something is going badly wrong, because as it was shown at the prize session, it was a full screen. I'm seeing if I have a full screen printout that I can hold up to the camera. This might be a little better, maybe not by much.
I don't think that's necessarily working with the background thing. We're just getting your background.
No, it won't work. Okay.
No.
Well, it has some fascinating people in there. But what I was trying to make is that of the 60-some physicists in that picture, 59 guys and me standing next to Willie Fowler, and 2 over is Maurice Goldhaber, from whom Willie Fowler was guarding me. But there is my favorite picture of John Bacall receiving the Dan David Prize from Israel a couple decades ago now, with his wife and their 3 kids. And there is Ray Davis. And there is Maurice Goldhaber. And there's the paper that actually came out of the Solar Neutrino Conference. I assume Reines asked me to be at the conference with the intention that I should write up the paper and edit the proceedings, which in due course I did. And I apologize that the picture is not a success. Yes, here's another example of this sort of sociology. That's a radio astronomy meeting. It's got to be a radio astronomy meeting because the lower right-hand corner, that's John Hay, the chap who first detected radio emission from the sun during World War II as a noise. When radio astronomy was noise and the signal was radar. And next to him is Francis Graham Smith. Next to him is Franco Pacini, whom you'll meet again in a moment. Next to him is Peter Scheuer. And next to him is me. And if you look hard, you'll see another gal a few rows back. That's Kuno Hofmeister's daughter, whose surname is now Meyer or Mayer. Bottom line, she's both the daughter and the wife of another astronomer. The other half of the room, okay, the front row, there's Willie Fowler and Gary Steigman and so forth. And if you look a couple of rows back, there is Janet Clinch, later Janet Jones. And that might be it as to women at that meeting. This was not untypical. In fact, I've looked at the list of speakers for a conference coming up later this month, and it looks as if of the speakers listed, I'm the only gal on the first day and one of 2 on the second day. This is the staff of Mount Wilson Palomar Observatory in 1972. Unfortunately, I believe the sidebar is completely covering Jim Gunn, but you'll meet him later. There's Martin Schmidt, tall in the middle, and my thesis advisor, Guido Munch, fourth from left in the front row, and Jesse Greenstein next to him, Babcock next to him, Bev Oak, Olin Wilson. But typical gender balance of the day. Incidentally, I think that battle has been won. Here's another of these interesting photos in this respect. You will see three gals in the third row. That's the secretarial staff, Geraldine and Angie, and I've forgotten the third name. But there is Trimble, lower left corner, between Steve Hawking and Martin Rees, now the Astronomer Royal. Next one over is Lodewijk Bolcher, who was Director General of the European Southern Observatory for many years, then Fred Hoyle, then Giant Narlikar, who's still alive and I think still believes in steady state or some form of it. Don Clayton, Wall Sergeant, Willie Fowler, Jeff Burbage, they are no longer with us. Yeah. Both my father and my husband had high-level security clearances, which nobody would give me because anytime I learn something, I want to tell everybody. But 1953, plus or minus maybe a year, my father came home from work and said they found 2 new moons of the Earth. It turned out to be true. They were radar detections. Tombaugh said he couldn't find them optically, but there have been several earlier and later cases of temporary moons of the Earth. They seem likely to be asteroids, probably temporarily captured in the Lagrange points, because there is Kazimierz Kordylewski, who predicted in 1951 that there should be extra moons of the Earth in those Trojan points corresponding to the Trojan asteroids of Jupiter, but trapped by the Earth. And what he found in the end, wrong direction, was clouds there. My lesson is there's always new stuff out there, something new to be found and shared and thought about. We don't always teach science that way. Okay. There we go. We don't always teach science that way. Maybe we should. There's my father and one of his business cards, not advertising what he really did, which was attempts to make the images on magnetic tape visible, but advertising ouchless earrings made with magnetic little baby magnets. As per Fritz Vicky, the good Lord had to say light and magnetic fields. There's Kordylewski, with a telescope of his own design and building and invention. It's a very strange telescope, I think you have to say. And the IAU announcement card in which he reported the detection not of asteroids or planetoids or moons captured at the Trojan points, but dust clouds, which were confirmed later from OSO something or other, I don't know. Weak gravitational lensing. It wasn't called that when it was first discovered or first calculated. It was called a limit on the angular resolution of galaxies and their use for cosmology, due to what was then called gravitational scattering of light. And the idea apparently originally came from Richard Phillips Feynman. The thesis advisor on this project was, again, Guido Munch. And you're going to see the person who wrote the thesis in a minute or two or three. But there is the title, Mathematical Framework for discussing the statistical distribution of galaxies in space and its cosmological implications. Thesis defended in October 65, PhD awarded in 1966. And the writer, in fact, served in Vietnam. Our students are protesting right now outside this building, which is now under lock and key. And my generation protested the Vietnam War by registering for the Peace and Freedom Party, sometimes going out on the streets and shouting, hell no, we won't go, but mostly not making encampments on the Caltech campus. But there is Guido thanked as the thesis advisor. Yeah. There's Feynman thanked for the idea. There is gravitational scattering of light as the phenomenon. And the dedication in English and also in Elvish. Once upon a time, we all read the Lord of the Rings trilogy and made great things out of it. We used to have Hobbit parties where we all came dressed as characters. And since there weren't very many women, it wasn't so bad. There weren't very many women in the book either. But Galadriel was popular. But this is in Elvish a dedication of the thesis to me. And there is the moment after the thesis defense. And what you see is Trimble and thesis defender Jim Gunn in the door of his office, pretending to look the other way and holding a cigarette in his hand is Guido Munch, who is thesis advisor for both of us. And walking away, being taller than anybody else in the picture, is Robert Christie of the Christie bomb from World War II. And you'll see the front of Robert Christie in another context in a few minutes. Binaries with black holes, neutron stars, Cygnus X1. 1965 to 68, the idea came from Oktay Gazanov, who was in Moscow working with Zeldovich. He was from one of the republics in the lower right-hand corner of what used to be the Soviet Union, Azerbaijan, I think. And he had the idea that you could find they weren't called neutron stars and black holes in those days, they were called collapsed stars, but you could find them, this endpoint of the life of a star too massive to become a white dwarf, by looking for stars that were binaries, because you could see a change in radial velocity with a period and measure the period, but you couldn't see any light from the other object. So I'm flipping through my copy of this to try to find my lecture notes. Never mind. Up until a couple of days ago, I actually thought I was supposed to be giving a talk called Oppenheimer and the Cosmos about J. Robert Oppenheimer, nothing to do with the war, but the facts of his involvement with neutron stars and black holes before the war, and his interest, strangely, I think, in astrophysics in the 1960s. He was at the very first Texas Symposium and attended several other conferences. And I will just say he did not cover himself with glory at that point. But Guzanov to Zeldovich to Kip Thorne, who was spending time in Moscow at one point, to Trimble, who had just defended her thesis. And Kip said, my first post-PhD paper should be something with him. So this is what we did. We looked for spectroscopic binaries with a single set of spectral features from a massive star and a companion that did not emit any visible light. We didn't find any. On the other hand, the basic method is exactly what led to the identification of Cygnus X1 as a black hole in 1972. And I had the privilege of writing the last fundamentally wrong paper about Cygnus X1. I knew it was wrong at the time, but I wanted to provoke some observations. And one way of getting people to do things is to make a prediction that they can then falsify. And my idea was simply to say, well, suppose the visible star, which is HD 226868, is not a massive blue star, but a low mass blue star of the kind that you find post red giant stage as a horizontal branch star, a Hamasenzwicki star, a star of the kind I just recently done models of using the Paczynski code, which you may or may not meet again in a few minutes. So suppose the primary was like that, then when you do the arithmetic, the companion could be a neutron star, doesn't have to be a black hole, and it would be close to us. So I mentioned that during the half a year I was in the University of Maryland, and Bill Rose said, that's a nice idea, I'd like my name on the paper. Okay, now, if Trimble, who was then an assistant professor, Trimble and Rose published, it's going to be remembered as Rose and Trimble because he was senior to me, better known, ... So what do I do? Okay, make it Trimble et al. By adding my husband's name. So the paper is Trimble, Rose, and Weber. And what we did was to say, well, if it's one of these low mass blue stars, it'll be close to us. And that led in turn to some optical astronomers doing better spectra to get absorption features from gas clouds in the spiral arms of the Milky Way, thereby showing that the object Cygnus X1 or HD 226868 was on the far side of a couple of spiral arms. The original detection, of course, was an X-ray flare of Cygnus X1 observed from the Uhuru satellite, the first X-ray satellite, an absolutely brilliant contribution, of course, from Riccardo Gicconi, who in due course won the Nobel Prize for it. My Gicconi story dates from an AAS meeting in Nevada. We were sitting having snacks or something before dinner, and there were slot machines right next to us. And Gicconi says, "Have you ever played a slot machine?" And I said, "No, I'd never gambled at all." And so he held out a fistful of quarters to me, put them in the slot machine. He thought he'd given me enough quarters that I would win something and therefore get hooked. I put all the quarters in the slot machine, didn't get back anything. So I said, "Riccardo, for that we could have had a nice glass of wine each." So then he had to buy me a glass of wine as well. That's my Riccardo Gicconi story. Not characteristic, but bottom line is radio detection of a radio source in the same general direction as Cygnus X1 when it flared by Bob Gelming. And that led to an optical identification and to the radio velocity curve that then, when interpreted sensibly with the visible star as a main sequence star of 20 solar masses or something, gives you a black hole of 6 or 10 or 16 solar masses. It's grown over the years, not physically, but because of different interpretations. This has a sad story as well. It was not, HD 26868 was not in the catalog of binary stars, single lines, to be looked at because it had been observed for radial velocities 3 times by Daniel Magnus Popper. And sadly, he happened to observe it at times separated by an integral multiple of the orbit period. So he observed it 3 times and found the same velocity each time. And so he did not include it amongst his binary stars to be studied later. Nevertheless, later evolution of these things was worth studying. And the statistics of the stars with orbits in the catalog, which is due to Alan Batten, suggested that there should be quite a few massive binaries, which is, I think, now true. On the other hand, I didn't know that territory was defended when I did that bit of analysis. Previous one was from Kuiper in 1935. I figured, by the 1970s, you'd be able to do better. But it was submitted and refereed, I guess, by Carlos Jacek, who defended that territory, and who referred in his report to the incorrect methods of Trimble. The editor, Helmut Abt, then stopped that paper. It was never published, at least not in the journal to which it was first submitted. And the editor told me that the remark came from Jacek. A few years later, the Patras IAU, I found myself in the lunch queue right behind Carlos Jacek. Do I run? What do I do? I stepped forward, held up my hand and said, "How do you do, Professor Jacek? I'm Virginia Trimble." He then had to introduce me to his wife. And I think it's fair to say that we remained friends thereafter. A few sidebars. Okay, here's the spectroscopic binaries and collapsed stars paper, Trimble and Thoring from 1968, yes. There's the low mass primary for Cygnus X1, Trimble, Rose, and Weber. That's what I was doing in 1963. I was being Miss Twilight Zone. That's Rod Serling. We're holding a Twilight Zone script. And the shtick was I was supposed to be a scientist who read the scripts for scientific accuracy. I actually did. They even made a few changes that I suggested. They'd confused things like galaxy with solar system. But I also toured for Twilight Zone to all the cities used for the Nielsen ratings. The purpose of the exercise, Twilight Zone was going to have its last series of new programs. They wanted a large viewership, which would raise the price of the resale value of the programs. Twilight Zone ran for like 5 years. And so I went to the Nielsen cities where the ratings were determined. Houston, Dallas, Chicago, Cincinnati, Pittsburgh, New York, Boston, Washington, Cleveland, Frisco, LA. I can still say them in the same order I visited them. And I did morning wake-up programs and television interviews and newspaper things and so forth. So there I am with Rod Serling. Oh yeah, that's 1965. That's the party held right after Richard Feynman's Nobel Prize was announced. Sitting next to him on the sofa is his sister Joan, who died not very long ago. On the far left is his wife Gwyneth, and that's Trimble in what was in fact a red velvet dress on the right. And if you've ever read Surely You're Joking, Mr. Feynman, I was the graduate student who posed newt for him when he was learning to draw. This is 1969. That's Howie Laster on the left, Cart Westerhout on the right, and in the middle, Joseph Weber, from the press conference held when he first announced a possible detection of gravitational radiation. And hidden there where you can't see it back next under the sidebar is a numerical estimate of the strength of the Riemann curvature tensor as 10 to the minus 24 somethings per cubic centimeter. Gravitational radiation from binary stars is true. It's now obviously true because of LIGO, but it was true even for stars like the cataclysmic variables. And this was really a report because the possibility had been announced 3 different times by Kraft, by Paczynski, and by John Faulkner. And then there's the 3-degree isotropic black body relic radiation. It came as an APJ letter to the Robinson Library at Caltech. We never doubted it, really. But I think one of the fun bits of that is Gamow at the 3rd Texas Symposium, also hidden partly under the sidebar. First Texas Symposium was 63. Oppenheimer and his brother were both there. Second one was 64. So the January 67 New York, Texas Symposium was the first one after the discovery of the microwave background radiation. It was also the first big conference I went to. I used my Christmas check from my grandmother to go to it. I didn't know that scientists got money from government in those days. Anyway, my first Texas Symposium, a number of amusing things happened. One was that Gamow said publicly, well, okay, he was the guy who did alpha, beta, gamma, the idea that nuclear reactions occurred in the early universe and that there would be radiation left. And so he's, having predicted that there should be 5 degrees of radiation left, said, well, I lost a nickel and you found one. Who's to say it's the same nickel? He apparently wasn't entirely persuaded that Penzias and Wilson had actually found the radiation that alpha, beta, gamma, well, alpha and gamma anyway had predicted, alpha, Herman, and gamma. That remains a mystery. He also bought me a drink, Gamow. We were sitting at a table in the bar, and he sketched me as the redshift girl because I was wearing a red and black nylon dress, which I should have worn it today. I still have it. I still have all my clothes. And Jesse Greenstein had given a talk about the gravitational or Einstein or relativistic redshift in the spectra of white dwarfs, which was my second-year research project. I think he might not have even credited me if I hadn't been there, but he sort of had to since I was there. Another microwave background story. The Kobe satellite, John Mather, got the spectrum, and he showed it at a AAS meeting. It was the most beautiful black body that any of us had ever seen, and the audience broke out into spontaneous clapping. Not a standing ovation, but a spontaneous applause. And Jeffrey R. Burbridge, who was chairing the session, said, what are you clapping for, the universe? He still didn't believe in a microwave background from an early hot dense universe. I think he never did. John Mather also won the Gruber Cosmology Prize, which, the most recent Gruber has just gone to Marshariki. It was announced like yesterday or something. And I got to introduce John Mather when he gave his Gruber Prize talk at an IAU General Assembly. And we had very different childhoods. He got taken to the big city a few times, whereas where I was, they brought a cow to see us because we would never have seen a cow. And quite recently I was asked, does anybody still believe steady state? And I was asked to give a conference, to go to a conference, asked to give a talk at a conference on a subject about which I know nothing, honoring 3 people whom I've never met. So I thought I would go. And I've now put together a talk on human rights for them, which they asked for, and a topic on how science changes its mind, not scientists, how science changes its mind, the decline and fall of steady state cosmology, to be given later this month at Rutgers. Okay, there's George Gamow, who predicted the microwave background. There's John Mather, who got the spectrum. And there's Jeff Burbidge hiding behind the sidebar again, looking grumpy. But that's his picture from annual review, so you can find it for yourself in annual reviews. And this is the abstract of the presentation that Mather gave. Quasars with a redshift of 1 or 2. Martin Schmidt, who of course participated in the first discovery of quasars, came running down the hall one day saying, "Do you want to see Lyman alpha?" He had just found a quasar with a spectrum that showed a redshift of about 1.9. He gave a colloquium at Caltech on the subject, and as the picture of the spectrum went up, Gunn said, "That's important for cosmology." It became the Gunn-Peterson effect, also written up by Scheuer in Nature at the same time. This is 65. And then I shared observing time at Mount Wilson, at Palomar with Chip Arp. He was the 200-inch observer. I was on the 48-inch getting spectra of the Crab Nebula for my thesis. And Arp, it was pouring rain. But you know, when you have access to the world's largest telescopes, you don't actually give up and go to bed just because it's raining. You stay up in the hopes that it will dry up. It never stopped. And eventually my thesis advisor showed up and took me down the hill. He didn't want me spending the whole night with Chip Arp. But in the meantime, Chip had showed me some of his images of galaxies with active star formation and a quasar on either side. And of course, the galaxies had small redshifts and the quasars had large redshifts. And he found a bunch of these. And he gave a talk about it. And he said, well, if you look at 9 constellations and see 7 Big Dippers, what do you think? Well, we do actually see 3 Big Dippers. We do actually see 3 Big Dippers. Big Dipper, Little Dipper, and the Pleiades is the same shape. Bottom line, I tried to advise Dr. Arp. This was foolish, but I tried to advise him. I said, it's absolutely fascinating. Write it up and go back to what you were doing before. If he'd taken my advice, would it have made a major difference in his life? Yes. So there's Martin Schmidt. There is an early quasar image with the bright nucleus and the jet, which shows, if you take it naively, speeds faster than C. But of course, you have to use special relativity and interpret it correctly, or you think you're violating special relativity, but you're not. There's Bruce Peterson, Gunn-Peterson effect. There's Chip Arp looking grumpy. Pulsars and the Crab Nebula. The light first reached Earth in 1054. It was seen by Chinese and Korean astronomers, probably by one Arabic writing scientist in the Muslim community. Apparently not recorded in Europe at all. They were busy having the Dark Ages or something. The first I knew about it was my assigned topic, the Crab Nebula, for my thesis. The first I knew about pulsars was in the spring of 68, had a letter from Peter Scheuer in Cambridge saying that it had a visit from the little green men. And the serious radio astronomers got longer letters from Hewish with more details. The source had first been seen in 1965 by Hewish and Samokoyo, but their angular resolution was not good enough to identify it with any one star. If Okoyo had stayed in England or in the US when he came here, it would probably have been a different story, but he went back to Nigeria to try to build up science there quite successfully. He established the first PhD program in astronomy. It was radio astronomy at the university there. Meanwhile, pulsars were known in Cambridge. I spent the summer of 68 there, and we were all trying to be sure of the timing mechanism. And John Faulkner tried to make the timing be white dwarf pulsations, which really didn't work. But one fine day, Robert Christie, who was there on a sabbatical, came dashing out of his office saying, you couldn't do it with a planet orbit because the planet would be torn apart by the gravitational force of the neutron star. He'd rediscovered the Roche limit. Whereas the 1969 Rome pulsar meeting, we all discovered that both the rapid rotation and the strong magnetic field of neutron stars had been predicted previously by Pacini and Vulture. And Scargill showed his image of the motions of the continuum emitting features. You'll see the picture in a minute of the structures around the pulsar in the center of the Crab Nebula. So we had Vulture saying in the summer of '68, as usual, the distance to the Crab Nebula has been over-discussed. That was the topic of my thesis, you understand. This is not a complimentary remark. Stony Brook Summer School that same summer, the first ever open source astro code, the Paczynski code to do stellar evolution, which I used then to try to make an alternative primary for Cygnus X1. And Jocelyn Bell Burnell at the 5th Texas, and we're keeping her for last for me, a reason I will tell you in a moment. So there's a drawing of the central region of the Crab Nebula. The star E is actually the pulsar. Some of the fainter ones show up in standard images. The star things and the dots and so forth are the centers of the expansion of the nebula around the pulsar. My thesis was actually called Motion and Structure, the Filamentary Envelope of the Crab Nebula. There's Sam Okoye in native dress from an IAU symposium. I don't remember which one. I told you you're going to see Bob Christie from the front, but there's Bob Christie, I think at the party celebrating Gunn's thesis. And it must be in the evening because I've changed my dress and put my hair up and put my contact lenses in instead of the glasses that were tangling with Jim's glasses when he defended his thesis. But there's Bob Christie rejoicing over something, I don't know. But he was the one who said, you know, you can't time a pulsar with a planet orbiting it in the way that you time the radio emission of Jupiter with the orbit of Io around it. There is Scargill's sketch of the central region of the Crab Nebula from a series of photographic plates exposed mostly by Walter Baade. Baade took plates in both continuum emission and line emission, and Munch, who inherited the stack and continued some of the series, divided the plates into 2 stacks, one with the continuum emission, one with the line emission. He gave the continuum emission plates to Scargill and the line emission plates to me. He almost certainly thought that the continuum was a better bet. I think he was wrong about this because I think I managed to stay in astronomy longer and more tightly than Jeff Scargill, who's now mostly known for the Lamb-Scargill periodogram, I think. Anyway, there's the center, and there is Scargill's drawing of the time development of the positions of one of the wisps in the picture. And he's got the top, move it to the top, there. Actual data going through 2 periods, 3 periods, and the dotted line shows the motion outward. Notice that after that 3rd one, he has only dots along almost a straight line, but he's drawn the period continuing to operate through that period when the wisp wasn't moving. He showed this at the Rome Pulsar meeting. And Jerry Ostreicher piped up, yes, I can see the canals, like Mars. That is actually from the Rome Pulsar meeting. That's Trimble on the right, partly obscured. Then Jeff Scargill and D.W.M. Stibbs and Peter Scheuer on the left. And there is Jocelyn Bell Burnell and her telescope. And I want to end with Jocelyn. She was asked to give the after dinner talk at, I think, the 5th Texas Symposium. She did so very, very, very elegantly. She was wearing a very elegant dress, and they gave her a clip-on microphone. She said, well, a male chauvinist pig microphone intended to be clipped to a gentleman's tie and the transmitting device held in a gentleman's jacket pocket. She also said, and I quote, roughly, I think, "There comes a time when you don't remember what happened. You only remember how you told the story last time." So you have now heard a variety of stories, remembered it as how I told them last time. So let me bring this to an end and invite questions, comments, or rude remarks.
Thank you so much, Virginia. That was incredible, and such an amazing trip through your life against these such well-known names through astronomy. But yeah, we're getting some applause here. I'm going to take you off the share, and then we can see everyone a little bit better. Yeah. Maybe not that. Maybe a picture. There we go. There we go. Right, got there in the end. Not normally doing the hosting. I see we've already got a question in the chat or two, so maybe we'll start there and then I'll hand it round the group. So this one is from Horace Smith, and I don't know. Horace, do you want to
Hello.
ask your own
Hello, I'm
question?
just on sound here.
Would you like to ask your own question, or do you want me to ask it?
Oh, I can see it. I was interested to hear Virginia's comment on the radar detected satellites, natural satellites, because I remember in the early 1950s, 1954 or thereabouts, a lot of US newspapers at least headlined the detection of two satellites with orbits at 400 and 600 miles by radar, but they were never
Radar from an
confirmed
airplane.
as far.
Radar from an Air Force airplane with an Air Force pilot. Yes, that was my
But they were
father's
never confirmed. At least the Air Force denied that they had detected them.
Yes.
And they, of course, I suppose the radar was pretty poor back then compared to what we have now. So whether they ever existed, I don't know. The Air Force would not officially confirm them. And I
You
guess,
have?
as you said, Tombaugh didn't find them later on. So I don't know. They live in UFO history, however.
No, I think they were almost certainly real and briefly there. I think the orbit sizes were wrong, because I think the pilot who reported them had really had only 1 point, and you need 3 to get a decent orbit. Even Newton needed 3 points to get a decent orbit. I think very probably there was something there briefly, just as there are now gas clouds. I'm lying to you, dust clouds at the Lagrange points. But they were not threatening. They were not foreign ballistic missiles of any kind.
I wondered whether the Air Force not confirming them was in part because they didn't want to give away any radar capabilities at the time.
That's not impossible. I'm currently teaching Impact of World War II on the Sciences, and I just hit radar this week. And the rapidity with which they improved time duration measurements for radar proximity fuses and the frequency separation to get velocities, the progress was enormously rapid. It led not only to radio astronomy, but to things like the Lamb shift. And I think by 54, radar had made a lot of progress, and we didn't necessarily want to admit it.
Oh, thank you.
Thank you. Thank you, Horace, for your question. Is there any more questions from the group?
Or comments or rude remarks?
Comments are always nice.
If I may make a comment, Jocelyn Bell-Burnell is speaking this weekend at the BAA's spring meeting in Greenock in Scotland, and if the British rail system works, then which is not guaranteed, I may well be there to see her.
No, she was our Fred Reines lecturer a couple of years ago. She's a wonderful guest. She talks with students and she eats what she serves. She's just a wonderful guest. Willie Fowler also, I invited him for a colloquium not long after he got his Nobel Prize. Willie Fowler was also a wonderful guest. Richard Feynman was not.
Do you want to expand on that? Or
Sadly, it was one of the last talks he gave before he died. He refused to allow us to pick him up. And he took the word from a particle physicist that you could get here from Caltech in 45 minutes. And so he arrived late and frazzled and angry, and he refused food and drink afterwards, and he refused the honorarium. He said, give it to a charity. He was not fun. He was lots of fun other times. And he sometimes would even listen. I mean, he didn't like silence. So either he was talking or somebody else was talking. And if he didn't like what you were talking, he would shove you on something else. He got tired of my husband, Joe Weber, talking about gravitational radiation. He said, oh, that's enough with gravity waves. Go look for something else. Go look for neutrinos. So my husband built a neutrino detector, which probably worked.
okay, is there anyone else? You've all been very quiet tonight. They've all been astounded by your story.
People aren't good about asking questions after history talks. I think they're afraid to admit they're old.
Perhaps you could
Hopefully not yet.
perhaps you could tell us a little bit about The Sky is for Everyone.
It's a book. It's a book of autobiographical chapters by women astronomers. The idea came from David Weintraub, and Princeton University Press had already agreed to publish it by the time I joined the team. The idea was, since it's about women, there should be a woman editor. I also wrote one of the chapters. It was some of our, they're 30 some, and several of them are written by British women, American women, but also women from France and Mexico and Brazil and South Africa, women from all over the world, except, well, we didn't do well on, we've got 2 women from India, none from China, but no, 1 from China, none from Russia. Okay, anyway, bottom line, several of the women said that writing up their lives in this way had been very difficult for them because they'd had real struggles. That wasn't true for me. I mean, I took the easiest path right from Toluca Lake Grammar School through LeConte Junior High, Hollywood High School, UCLA, Caltech, postdoc, faculty position. I just took the easiest possible route. And if I made messes, I'm sorry. But if things were hard, I never suffered when anybody else did. If there were messes, I'd made them myself. So
you must have come across some barriers yourself, though, and being a woman in an industry which was predominantly male. When you were showing those images early on of yourself and just 1 or 2 other females in the room, and
sometimes none. I mean, this thing at the end of May in Rutgers is okay. Let me quote another British-born woman astronomer, Anila Sargent, who remains a good friend. We were graduate students together at Caltech, and she did her first degree in Glasgow. And when she arrived in Glasgow as a physics student, she said, "Oh, look at all the lovely men." That has always been my attitude. It didn't bother me being the only woman. It just, if there were disadvantages, they were matched by the advantage that you could get to know anybody you wanted to know and ask questions and be paid attention to. I think that must have been Oppenheimer's charm. I think when you had his attention, you had 100% of it. That was true also of Feynman and not true of some other people. But I think that may have been Oppenheimer's charm.
thank you. Okay, so any last comments or questions?
Can I ask a question, please,
Yes,
Caroline?
Yep, Phil, if you want to go ahead.
Okay, well, everybody's been very quiet, so I thought I would come up with
I've got to be able to hear you if I
thank you. Sorry?
If you can speak clearly, Phil, in like you did there, that would be good.
louder or
Yeah.
something.
Okay. Dr. Trimble, thank you very much for a very interesting talk.
Thank you for
I've
listening.
followed your career for a very long time.
Sorry?
I remember your reviews in the journal Nature, in which you proved that one British saying was quite incorrect, that Americans have no sense of irony. I remember one of your articles, I can't remember the subject matter in astrophysics, but you brought into it some comments about the late President Ronald Reagan. I remember it made me laugh anyway. But I was wondering, in your long career, is there anything, if you had more time, you'd wish you'd been able to do that you haven't done in your life?
I believe all my sins were sins of commission. I did not have children. That was a deliberate choice.
Yeah.
My husband actually already, and his first wife died before I met him. But he and his first wife had 4 sons, and that seemed to me that fulfilled not just Hillel, but Shammai. He said I could have as many children as I wanted. He would provide the 2 essentials, sperm and a positive balance in the checking account. And I figured that 0 was a good choice. I mean, there are 1,000 branch points. Isn't that why we want multiverses? It's like wanting reincarnation or wanting personal immortality, a chance to make a different choice at lots of different forks in the road, like Stan Deser's book, Forks in the Road. When you come to a fork in the road, take it. Wouldn't we all like to be able to explore what would have happened if we'd made different choices? I think that's the charm of the multiverse. You're not on that other branch, but somebody quite like you is. I was offered different jobs. When I got my PhD, I had 5 different job offers. When I came back to the US, I had 3 or 4. And it would have been interesting to see what would have happened if I'd taken a different job, for instance. I
Okay,
refuse to
thank you very
consider
much,
what would have
Beth.
happened. Sorry, what, Phil?
I'm saying thank you very much for your reply. You are a very wise person. Thank you.
Oh dear, nobody's accused me of that before.
Thank you, Phil. Okay. If that's everyone, we're going to say thank you ever so much for your time, and we're going to sign off. So we're going to give you a round of applause. Thank you very much, Virginia. We've really appreciated your time. I'm going to stop the
Thank you, Beth.
recording. If I can stop the recording as well.